Good morning. This lesson is for my Honors Integrated 1 class and my Integrated 1 class. But before I get started, I want to say I hope that everyone is doing all right out there. I don't know what I'm going to title this. It depends on what class you're in, and it depends on how I'm going to title it. But what I do know is that this is part 1 of the lesson, and we have one goal for this part. And it's going to be defining angle pairs when two coplanar lines, are intersected by a third coplanar line, which is a transversal. So we're going to just review some things and then get into this, what type of angles are created when two coplanar lines are intersected by a third coplanar line. Alright, so let's review. Two coplanar lines mean that both lines are on the same flat surface. So here's an example of coplanar lines, right? Line AB and line CD are coplanar because both are on the whiteboard, and the whiteboard is a flat surface. So we would consider these coplanar. Let me write that down. Coplanar. These guys are coplanar. Same flat surface. A transversal is a line that intersects coplanar lines at different points. Now, there's an implication about a transversal. If it intersects coplanar lines at different points, that means that the transversal line must also be coplanar. It couldn't do that if it wasn't coplanar. So all three of these lines are actually coplanar. And here's an example of a transversal intersecting coplanar lines. Here are my coplanar lines. And this is my transversal because it's intersecting at different points. It's intersecting at this point, and it's intersecting at this point. And so now that we have the picture of what we're going to be working with, we can now start to talk about the angles that are created from this. So let me erase this board. I'm going to come back and set up the next part of this first lesson, and I'll be back. I'm back. So let's go ahead and continue with our goal today. And I want to remind you that we are defining angles created by a transversal. My grammar's so bad. Created by a transversal intersecting two lines which are coplanar. It will be helpful in memorizing the angle pair names and positions if we describe some features of the picture we are working with. So I want to talk a little bit about this picture, because if we understand a few things, I really believe that will help us understand the names of these things. So we have our lines right here, and we have our transversal right here. Between the lines, I'm going to call this the interior. Interior is between, right? Okay, so this is the interior, this is the interior. And again, the interior is between, inside the lines. Okay? So if between the lines is considered the interior, outside is considered the exterior. So we have exterior below the lines, and we also have the exterior above the lines. Now, the next thing I want to discuss is going on either side, changing sides of the transversal. I'm just looking for another colored marker. I'm realizing I'm running out of markers here. Maybe I hid it in my pocket. No, I didn't. So I'll just write this. So changing sides of the transversal is considered alternating. Okay, so jumping from one side to the other, it's a terrible arrow, is considered alternating. And the last thing I want to talk about, which will help us recognize our angle pairs, is this is a vertex and this is a vertex. Let me get out of the way so you can hit pause and make sure you get everything written in there. I apologize about my grammar. So again, between the lines is the interior, outside the lines is considered the exterior, and when we change sides of the transversal, that's called alternating, and this is my vertex, and this is my vertex. So let me go ahead and erase all this, and I'll clean it up, and we will continue this lesson, and I'll be back. I'm back, so let's go ahead and keep moving on with our goal. And so now I want to start talking about defining the angle pairs. And there are 4 types of angle pairs created by a transversal. All angle pairs do not share a vertex. I'm gonna underline that because it's very important. I get a lot of students thinking that linear pairs and vertical angles are angles created by transversals, but linear pairs and vertical angles do share a vertex. They share that point right there. That's a vertex. The angles that we're going to talk about today do not share a vertex. So remember that. They do not share a vertex. I want to also review with you the word corresponding. And that means same position. So top right and top right would be same position. Let me write that out as an example. So example, top right. So we would look for angles in the top right, the same position. All right. So our transversal creates 8 angles, and I'm going to name them 1 through 8. I'm going to randomly put them on there. You can put them in any order you want, but I'll write them as angle. We'll go clockwise. 1, 2, 3, 4, 5, 6, 7, and 8. They are 8 angles created by our transversal. Corresponding angle pairs are the following. They're the angles in the same position but do not share a vertex. So for example, angle 1 and angle 7 are corresponding angles because they're in the same position. Top, left, top, left. So angle 1 and angle 7 are corresponding angles, right? They don't share a vertex and they're both in the top left. Angle 2 and angle 4 are corresponding angles because they're both in the same position and they do not share a vertex. So angle 2 and angle 4. That's another pair of corresponding angles. Angle 3 and angle 5. Bottom right, they do not share a vertex. They're in the same position, so that's another pair of corresponding angles. So angle 3 and angle 5 are my corresponding angles. And my last pair of corresponding angles are on the bottom left. Angle 8 and angle 6, they do not share a vertex and they're in the same position, so that makes them corresponding angles. And again, these are created by a transversal. So angle 8 and angle 6. Alright. Now let's move on to our alternate interior angles. Remember, alternate means we switch sides of the transversal, and interior means that we are inside the 2 coplanar lines. So, and they can't share a vertex, right? So angle 8 and angle 4 are alternating sides and they're in the interior, right? So angle 8 and angle 4. So are angle 3 and angle 7. They're alternating sides, they do not share a vertex, and they're in the interior of the 2 lines. So angle 3 and angle 7. And I hope that you understand why I talked about alternate or alternating and interior before I got to this. So hopefully you see where the names come from. They're very descriptive and they let you know what they are. Alternate exterior angles. Again, they're going to alternate sides of the transversal, right? This is my transversal. And they're on the exterior. So angle 1 and angle 5, those are an example of alternate exterior angles. As well as angle 2 and angle 6. Both pairs do not share a vertex. They're alternating sides and they're on the exterior of the lines. So angle 2 and angle 6. All right, the last pair of angles that are created by transversal are the same side interior angles. Again, they have to be on the same side of the transversal. They can't share a vertex. So it's angle 3 and angle 4. As well as angle 8 and angle 7. right? And so these are the angles created by a transversal. And again, they do not share a vertex. One angle came from up top, and the other angle came from down below. So right now, you're going to be expected to recognize which type of angles these are. So I'd like to erase this and then come back and do some practice problems, and then we'll go ahead and call this lesson a day, so or part one a day. So let me clean this up, and I'll be back. I'm back for the last time, I promise. So let's go ahead and just jump into what I'd like us to do, and I want us to use this diagram to answer questions 1 through 6. So a really good idea for you right now would be to hit pause, draw the picture, write down the questions, and answer them. And then when you're done answering them, hit play, and let's see if we agree on the answer. So let me get out of the way. Hit pause. Try them on your own, and I'm back. All right, so let's go ahead and go through this. For problems 1 through 4, list all the exterior angles. Alternate exterior angles, sorry. So they're alternating sides of the transversal, and they're on they're in the exterior. So angle 8 and angle 4 are alternate exterior angles. You are correct if you said angle 4 and angle 8, that's fine. As well as angle 7 and angle 3. They're alternating sides, and they're in the exterior. Remember, they don't share a vertex. So angle 7 and angle 3. And if you make a mistake, make sure you understand what your mistake was. Corresponding angles. Angles that are in the same position. Top lefts, top rights, bottom lefts. And they don't share a vertex. Angle 8 and angle 2, they're in the top lefts. Those are corresponding, angle 8 and angle 2. Top rights, angle 7, angle 5. Bottom lefts, angle 1 and angle 3. Bottom rights, did I say bottom lefts? Bottom rights, angle 6 and angle 4. All right, same side interior angles. Angles in the interior that are on the same side, and remember they do not share a vertex. Angle 1 and angle 2. As well as angle 6 and angle 5. Okay. Number 4, alternate interior angles. Remember, they're in the interior, they alternate sides, and they do not share a vertex. So it looks like angle 1 and angle 5 are alternate interior. As well as angle 6 and angle 2. That's not a very good angle symbol. Angle 6 and angle 2. All right, so I've done problems 1 through 4. For problems 5 and 6, what can you say about angle 8 and angle 6? Angle 8 and angle 6, they are vertical angles. Because the sides of 8, if I extend them, make 6, right? And not only can I say that they're vertical angles, but remember we know that vertical angles are equal. So they are vertical and equal. So I'll say and the measure of angle 8 equals the measure of angle 6. All right, what can I say about angle 2 and angle 3? Angle 2 and angle 3. I'm going to cover it up like that, and I'm going to cover it up like this. Those are a linear pair. They're a linear pair. They are a linear pair. Let me stress that with some color here. I think they make this ink out of seagulls. So they're a linear pair, and what do we know about linear pairs? They add up to 180, or they're supplementary. So I know that the measure of angle 2 plus the measure of angle 3 will add up to 180 degrees, which makes them supplementary angles. All right, so I'm going to go ahead and end part 1 of this lesson. Again, I hope everyone is doing all right out there. Have a good day, everybody. Bye-bye.